Hi, students. Uh, this is Professor Sanjay Gupta. I think most of you know me already, right? I have been helping some of you learn few things in mathematics, statistics, economics, or physics, right? So I decided to start recording some YouTube videos, right, which can be, made available to the students so that they can refer to some of the key things in a certain topics that I have identified. So based on my experience of taking online sessions for the last few years now, I have identified a few topics and I'm starting now my this YouTube videos by taking the topic of completing the square. So the very first topic that I'm taking today is going to be completing the square because this topic has lot of applications and most of you may not be aware of all the applications, but as we move forward, I'll be recording all the applications and you will be surprised to note the applications and be able to apply this. First is we are doing the topic of completing the square. This is always applicable in case of a quadratic functions. So if we are given a quadratic function, and we have to do the completing the square method in that topic, then that is what we are going to learn today, how to write a given quadratic in the form of completing the square. And now once we are able to do that, then you will be surprised to see that there will be a lot of applications that will open up, right? Many applications of completing the squares are there. At least 5 applications I will cover in the coming videos. And one by one, all will be uploaded very soon in the next 1 week or so. Right. So let us today understand how do we complete the square and what is the mathematics behind it. Because some of you, I have realized, are not able to understand this from their schools or colleges. So let us first understand the basic formula that we use in quadratic functions. We are all aware that x plus a whole square is x square plus 2ax plus a square. Right? And similarly, x minus a whole square is equal to x square minus 2ax plus k. This is the very first fundamental idea that we will use in looking at the procedure for finding the completing the square form of any quadratic function. This is the two formula that we use, x plus a whole square and x minus a whole square. Now this is called the completed the square form because some of you may not be even knowing what is the form. This is called completed square form. And this is called the expanded forms because we have expanded x plus a times x plus a called x plus a whole square. So this is the expanded form and similarly here also. This is also the expanded form. Right, and this is called the completed square form. So we can either write as x plus a whole square or x minus a whole square for any quadratic. Right, maybe it is multiplying with something outside, that will be later. But today we are going to cover some very basic quadratic function so that we can write x plus a whole square and x minus a whole square for each one of them. Okay, if that is this, these are the two formulas. Can I now just manipulate it a little bit to find out the value of, let's say, x square plus 2ax? So x square plus 2ax is going to be equal to x plus a whole square minus a square. Or if I have x square minus 2ax, then that will be equal to x minus a whole square minus a square. Right? What I have done is I moved this a square term to the other side, right? Which can be done by subtracting a square from both sides. That also you can do, or if you understand the transposition of the terms, that you understand that x square plus ax, right? So if we are given now in this form, if any question is given in this form, and we have to write the complete the square form, that means I have to convert it into x plus a or x minus a whole square. This is called complete the square form. Please understand. This is the complete the square, right? So if I take an example now, let's say we have x square plus 4x. I want to write the completed square form of this. So if you have a very good look at this, what is happening here is, if I have x squared plus 2ax, then what I'm doing is, I'm taking the x as it is. If the coefficient of x squared is 1, I'm taking the x as it is in the bracket. Plus this x coefficient here is 2a. So I divide that coefficient by 2. So it becomes just a. And then I square it. If it is plus here, then I use the plus sign. Okay. And minus of, we will also have to do minus of a square. So in the question x square plus 4x, the coefficient of x is plus 4. When I divide that plus 4 by 2, it becomes plus 2. So can I write it as x plus 2 whole square minus 2 square, which is nothing but x plus 2 whole square minus 4. Is that right? And similarly, if we had x square minus 4x, it would have resulted in x minus 2 whole square, still minus 2 square. This term you can see is minus a square, both ways. Right? This minus a square is there in both of this. So this has to be there subtracted always, not to be added anytime. So we do this. Is it right? So take this as the two core examples can be now built on this and try to say, let's say I want to do x squared plus 9x. How to write this in the completed the square form? I can say x plus, first ensure that the coefficient of x squared is 1. Yes, it is. So I can write x plus, now what is the coefficient of x here? It is 9. Can I divide it by 2? And then write just whole square of that. But that is not the enough. We will also have to subtract the square of this number. So you don't have to remember much. You have written this number now already along with x plus something. That something squared has to be done. Then only you know this identity works, right? Or this form works. So this is the completed square form. Now let us say if I have a question where x squared coefficient is not, let's say 1. What can be done? I can take this 2 outside and make the coefficient of x squared as 1. Is that right? Now I can apply the completed the square form on this. This is going to be x plus coefficient of x is 3. So I will do 3 by 2 whole square minus the square of 3 by 2. Is that right? And then we can just expand it again. We get 2 times x plus 3 by 2 whole square minus 2 times, this 2 is outside, see, out of the bracket. So it will multiply by both the terms in the bracket. 2 times 3 by 2 whole square is 9 by 4. And therefore finally it ends up as 9 over 2. Right? So this is the completed square form of 2x squared plus 6x. Right? Is that right? Now some of you may be asking, sir, sometimes we have all the 3 terms. Sometimes we have all the 3 terms given to us. Okay, let's have all the 3 terms. Let's say we have 2x squared plus, let me say, whatever, 10x plus 3. So I have all the 3 terms, the x squared term, the x term, and the constant term, and I want to write it as a completed the square form. So the rules are the same. First, take the 2 outside. So that the coefficient of x squared becomes 1. And keep the 3 outside. Don't take the 3 within this bracket. Keep the 3 outside. Just deal with the x squared and the x term with this. And now we have understood that we're going to write it as x plus 5 by 2 whole square minus the square of plus 3. So it ends up as 2 times x plus 5 by 2 whole square minus 2 into 5 over 2 whole square is 25 over 4 plus 3. Isn't it? And therefore it ends up as 2 times x plus 5 by 2 whole square minus 25 over 2 plus 3. It will be just as 2 times x plus 5 by 2 whole square minus 25 plus 6 is minus 19. Is it right? So your 2x square plus 12x plus 3 ends up as this form, which is called the completed the square form. So which is the form of like x plus a whole square, let's say plus b, right? And something also, let's say, so some constant has been taken outside. Let's say, generally we take a actually as this one, right? A is, is the coefficient of x square. So let us not confuse with that. Let's write down as a x plus b whole square plus c. Is it in this form? Yes. If I compare, then the a is 2, b is 5 over 2, and c is minus 19 over 2. Right? Most of the time, they ask you to find a, b, c by writing this in the complete to the square form. So completed the square form will have two terms either added or subtracted raised to the power 2 in brackets and then raised to the power 2. And you might have a term of a constant depending on what terms are given to you. Let's close this by doing one more question, which have now the negatives. So can we do now 3x squared minus, let's say, 12x plus 1? I want to write it as a completely the square form. So my first objective would be to take the 3 outside. X squared minus 4x. And now I can write this as x minus is there, so I'll bring the minus down. 4 divided by 2 is 2. So x minus 2 whole square minus the square of this 2. So we get 3x minus 2 whole square. This 2 square is 4. 4 multiplied by 3 would be negative 12. So finally we get 3x minus 2 whole square minus 11. So here if you compare with the standard form, then a is 3, b is negative 2, and c is negative 11. Right? By comparing the two form, a x plus b whole square plus c. Is that right? So if you have any doubts, you can, mention that in the comment box when you get this uploaded on the YouTube, right? And then you can, my telephone number is also mentioned there. You can share this with your friends, right? Ask them to subscribe the channel and ask any doubt whatsoever with me. Any student can ask any doubt because my mobile number will be available. He or she can WhatsApp me or my Gmail email ID also I will mention, and anything can be asked from this topic. Very soon you will also look at further videos on the application of this completed the square technique. But I hope now this is clear, and any student should be able to, or all students should be able to convert any given quadratic into the completed the square forms. Thank you very much for today. Thank you.